In this video, I'm going to go over some questions on kinematics and dynamics. I'll go over the question and the options that are given in the questions, and then we'll find out why the answer that has been selected to be the answer is the real answer. So starting off with the first question, the graph relates to the motion of a falling body. Which is a correct description of the graph? Now looking at the y-axis there, it is y against time. Now we are told that this is something that is falling, and so only speed or velocity will get to this terminal velocity that will be there, will reach that gradient that will be 0 over here. So you'd look for speed, so which means the answer is between C and D. Now C says y is speed and A resistance is negligible. Now when A resistance is negligible, then there is no terminal velocity. Remember, terminal velocity is reached when the weight equals the A resistance. So which means A resistance is not negligible. So your answer should be D for this one. Moving on to the second question. Which graph represents the motion of a car that is traveling along a straight road with a uniformly increasing speed? Now if you're told that the speed is increasing uniformly, it means that the acceleration must be constant. Uniform means constant, so you look for the one that is flat, so that will be between A and D. Then you look at the y-axis. So on the y-axis, it's supposed to have acceleration there, that is constant acceleration. So your answer should be A for this one. Number 3. A stone is thrown upwards from the top of a cliff. After reaching its maximum height, it falls past the cliff top, and into the sea. The graph shows how the vertical velocity v of the stone varies with time t after being thrown upwards. R and S are the magnitudes of the areas of the two triangles. What is the height of the cliff top above the sea? Right, so let's analyze the graph that is given here. So which means this stone starts off, it's given an initial speed of v as shown there. So this v comes to 0 at the maximum height. So when it is thrown up the cliff, it retards or it decelerates until it gets to the maximum height there, and then starts to fall down. So when it falls past where it started, that is the top of the cliff, and then continues to fall downwards. So which means there are two areas there. S should cover that distance to get to the maximum height, so that is getting to the maximum height, whereas R is containing S and also is part of the distance that comes from the top of the cliff downwards. So which means in order for us to get the correct answer there, it has to be the difference between R and S. Okay, the difference between R and S should give you the height of the cliff top above the sea. Number 4, a particle is moving in a straight line with uniform acceleration. Which graph represents the motion of the particle? The motion of the particle. So it's uniform acceleration. So if it's uniform acceleration, it means that the acceleration should be constant. And on a velocity time graph, acceleration is the gradient. So we expect a constant gradient on a velocity time graph. A there would mean that the object is not moving because there's no speed there. There's no slope, distance time graph. then this one would mean that there is no acceleration because the gradient is 0. But this one means that the gradient is constant, that is, the acceleration is constant. So that is the correct answer. So the answer is C. Then moving on, a projectile is launched at the top and follows the path OP, Q, R, and S as shown. Air resistance may be neglected. Which statement is true for the projectile when it is at the highest point Q of its path? So right at the highest point Q there. A says the horizontal component of the projectile's acceleration is 0. Horizontal component of the projectile's acceleration is 0. That is correct, because for an object to be thrown to follow this projectile motion, the horizontal component of the velocity is constant, so which means there's no acceleration in the horizontal. The only acceleration that is present is in the vertical, that is due to gravity. B, the horizontal component of the projectile's velocity is 0. Horizontal component of the projectile's velocity is 0. It's not 0, it is constant. It is always constant, it doesn't change. Kinetic energy of the particle of the projectile is 0. At Q, kinetic energy is not 0 because we still have a component in the horizontal. So that component in the horizontal gives the kinetic energy that we need to calculate. So C is wrong. Then the momentum of the part or the projectile is 0. Momentum is product of mass times velocity. So we cannot say that the momentum is 0 because we still have a velocity in the horizontal. Okay. Number 6. A car is traveling with a uniform acceleration along a straight road. The road has marker posts every 100 meters. When the car passes one post, it has a speed of 10 meters per second. And when it passes the next one, it has a speed of 20 meters per second. What is the car's acceleration? What is the car's acceleration? This one, I think we need to work it out. Right, so looking at it, we have from 0, the first marking is 100 meters. The second marking will be again another 100 meters. That would make 200 meters. Now using the equation v squared is equal to u squared plus 2as, v is 20, u is 10, and 2 times a times 100. We want to find a. So a will be equal to 20 squared minus 10 squared over 2 times 100. So that should give you 1.5 meters per second squared, and that happens to be B. Right, moving on to number 7. A tennis ball is released from rest at the top of a tall building. Now, when they say tall building, it means that air resistance cannot be neglected. Which graph best represents the variation with time t of the acceleration a of the ball as it falls, assuming that the effects of air resistance are appreciable? Yes, because it's a tall building. Right. If suppose air resistance was negligible, then remember acceleration was going to be equal to g and it was going to be constant. So that's what. Now, when there's air resistance, so it means that acceleration starts off as g. It cannot start as 0. For an object that is falling, the acceleration should start as g and then falls down to 0. So the only sensible answer there should be D. Number 8. A motorcycle stunt rider moving horizontally takes off from a point that is 1.25 meters above the ground, Landing 10 meters away is shown. What is the speed at takeoff? What is the speed at takeoff? Now this one we need to work it out again. Let's see. Right, so the stunt car starts 1.25 meters above the ground and lands 10 meters away, that is in the horizontal. So we need to find out what's going on in the horizontal and what is going on in the vertical. Remember we said that in the horizontal acceleration is 0 because it's moving at constant speed, it doesn't change. That's the ux that you want to find. And then in the y, when it starts, remember it says it starts moving horizontally, so which means there is no vertical speed in the vertical. And then acceleration in the y is 9.81 and the distance is 1.25 meters. So we can use s is equal to ut plus half at squared, where u is 0 because there's no initial or vertical velocity. So s will be equal to half gt squared. Then we know that s is 1.25, and then calculating that gives out t as 0.50 seconds. Now we then use this t because it's the same time that is happening again in the horizontal. So we use it in the way s is equal to ut plus half at squared, but there's no acceleration in the horizontal, so it's just s is equal to ut and it ends there. So t we have found is 0.505 and s is the distance 10 meters. And then we make u the subject. It's going to be s over t, 10 over 0.5, that gives you 20. Should give you 20 meters per second. Right. Moving on to the next question. Number 9. A particle moves along a straight line. A particular property k of the particle's motion is plotted against time. At any time, the slope of the gradient is the acceleration of the particle. What is the property k? Now this question clearly tells you that, okay, let's see, this one we said the answer is 20, that was it, and then this one, we said the answer was D. We need to put the answers there. Now, in this one, the question clearly tells you that at any particular time, the slope of the graph is the acceleration. So the slope of a vt graph gives you the acceleration, so which means this should be v. So there should be a velocity and not speed. So the answer should be D there. Number 10. A ball is released from rest above horizontal surface and bounces several times. The graph shows how for this ball a quantity y varies with time. What is this quantity? Now, as you can see, this is where the ball bounces. So the ball bounces here. So it starts off, in other words, it is released from rest. So it starts off with a v, just say that it starts off with the d that is equal to 0, right? And then it's going to, the height is going to increase, okay? So then it's going to get there, and then it will go down and then come back again to that point, then back again to the bouncing point. So we expect this to be displacement. So answer there should be B. Number 11. The diagram shows a velocity time graph. What is the displacement during the 2 seconds of the motion? What is the displacement during the 2 seconds of the motion? Let's look at the question. Right, so when they ask for the displacement on a VT graph, it's going to be the area under the graph. So the last 2 seconds are from 2 seconds to 4 seconds. So we go all the way up. So the area under the graph is what we're going to consider the area under this graph. Okay. So that's a trapezium, so it's going to be half the sum of parallel sides times the height, which is half of 6 plus 12 times 2. That's going to give you 18 meters. Okay. Right. Moving on to the next question, number 12. A supermarket trolley, total mass 30 kg, is moving at 3.0 meters per second. A retarding force of 60 newtons is applied to the trolley for 0.5 seconds in the opposite direction to the trolley's initial velocity. What is the trolley's new velocity after the application of the force? Now, again, this one we need to work it out so that we show how it's going. So we list what we have. We do have the mass, we do have the speed, the initial speed, that is 3. We do have time, 0.5 seconds. We do not have v. And then the force is going to be minus 60 in this case, because this force acts in the opposite direction to the motion. So we write it as minus 60. Now, using the formula, F is equal to the change in momentum over time. So force is equal to rate of change of momentum from that definition. So M is bracket V minus U over T. Then we simplify. So we're given the mass. So that mass is supposed to be 60. Then bracket V minus 3 over 0.5. And that gives you V of 2 meters per second. So that is that. Now, moving on to the next question, that will be number 13. The diagram shows a velocity time graph for a vehicle. The vehicle moving at 4 meters per second begins to accelerate at time t is equal to 0. What is the vehicle's acceleration at time equals to 3 seconds? Now, what you do there is you find the gradient of this line, because this is velocity time graph. So the gradient of a velocity time graph should give you the acceleration. So this is how you do it. You draw a tangent at that particular point. You don't just read the values. You draw a tangent because this is a curve. So you draw a tangent at 3 seconds there. And then you read off these values, the top value and the bottom value, to find the gradient of that tangent. And when I did it, I found 10 minus 2 over 6 minus 0. That gave me 1.33, which is about 1.3 to 3 significant figures, or to 2 significant figures rather. Yes. Let's move on to the next question. C. Number 12 is supposed to be, number 12 we said that was a C. Number 13, that's 1.3. Number 14, a small steel ball falls freely under gravity, being released from rest. Which graph best represents the variation of the height h of the ball? Variation of the height h of the ball. Now, the relationship that we have there is curvilinear. Why? Because we use the formula s is equal to half gt squared. But now our h is going to be negative because it is decreasing from that height h going down. So it has to decrease. So the answers were between B and C and D, but then since it is decreasing, D is wrong. D is correct when you are launching it. It is from the ground upwards. So this is from going down, so this should be the correct answer for that. Like I said, we are using S is equal to half GT squared. So the variation between S and T is quadratic, so it cannot be A in this case. Number 15, so this should be B. Number 15, a brick weighing 20 newtons on an inclined plane. The weight of the brick has a component of 10 newtons parallel with the plane. The brick also experiences a frictional force of 4 newtons. What is the acceleration of the brick down the plane? Assume that the acceleration of free fall g is equal to 10 meters per second squared. Right, so with this one we need to work it out again. So we're going to do that. Now, resultant force is what mass times acceleration is what we apply here. So the resultant force is supposed to be going downwards. So it's going to be 10 minus 4. The 10 going down minus the 4 is equal to mass times acceleration. But since we know that the weight is 20 newtons, we can find the mass by dividing by g, which gives you 2 kgs. And then we can now say 10 minus 4 is equal to 2 times A, because that's mass is now 2. And then A should be equal to 3 meters per second squared. Right, number 16. A force F is applied to freely, let's go back there. So we said this should be 3 meters per second squared. Right, moving on. Number 16. A force F is applied to a moving object at one instant of time. The object has velocity v and acceleration a. Which quantity must be in the same direction? Which quantities rather must be in the same direction? The quantities that are supposed to be in the same direction all the time is force and acceleration. Remember, resultant force is proportional to acceleration all the time. So our answer should be B in this case. Number 17. A ball falls vertically and bounces on the ground. The following statements about the forces acting while the ball is in contact with the ground. Which statement is correct? A says the force that the ball exerts on the ground is equal and opposite to the weight of the ball. B says the force that the ball exerts on the ground is always equal in magnitude and opposite to the direction to the force the ground exerts on the ball. That's Newton's third law. That should be correct. And then the force that the ball exerts on the ground is always less than it depends. It depends with the situation. Then the weight of the ball is always equal in magnitude and opposite in the direction to the force that the ground exerts on the ball. Again, it depends on the situation, the weight, and the force that the ground exerts on the ball may not be the same if there is deformation that occurs. Remember, Newton 3 forces are supposed to be of the same type, so they are supposed to be both gravitational. That was number 17. Number 18. The diagram shows a situation just before a head-on collision. A lorry of mass 20,000 kg is traveling at 20 meters per second towards a car of mass 900 kg traveling at 30 meters per second towards the lorry. What is the magnitude of the total momentum? Total momentum, right. Remember, momentum is a vector quantity, so we need to take into consideration the direction. Okay. So the lorry is going to the right, so that its momentum is supposed to be 20,000 times 20, and then the momentum of the car is supposed to be 900 times, so minus 900 times 30. So the total momentum, we subtract the two momenta, that gives us 373,000, which is 373 kilonewtons. Okay, hope that's understood. Right, moving on to next question, please. Number 19. A constant mass undergoes uniform acceleration. Which of the following is a correct statement about the resultant force acting on the mass? Correct statement about the resultant force acting on the mass. It increases uniformly with respect to time. So if it is uniform acceleration about the resultant force must not change, because remember we said resultant force is directly proportional to acceleration. So if acceleration is constant, resultant force must also be constant. So A is wrong. B, it is constant but not zero. That is correct. Right? It is proportional to the displacement from a fixed point. That is not correct. Proportional to the velocity. That is not correct as well. So answer should be B there. Number 20. A particle of mass m strikes a vertical rigid wall perpendicularly from the left with velocity v. If the collision is perfectly elastic, the total change in momentum of the particle that occurs as a result of the collision is... Now the particle hits the wall and then bounces off. So it means when it bounces off, the momentum is now negative. So it's going to be, if it's perfectly elastic, it means the speed that it bounces off with is the same as the speed that it hits the wall with. So it's going to be minus mv, which gives you 2mv to the left. It should be to the left there. To the left, because it's final momentum minus initial momentum. Final momentum is to the left, so which means it will be to the left. Number 21. Two spheres approach each other along the same straight line. Their speeds are u1 and u2 before collision, v1 and v2 after collision, in the directions shown below. Which equation is correct if the collision is perfectly elastic? Now, if it's a perfectly elastic collision, then we apply the formula that relative speed of approach should equal relative speed of separation. So it's shown here. u1 minus u2 is equal to bracket, so minus bracket v1 minus v2, which then changes to v2 minus v1 right there. So in this case, u1 is going to the left, to the right, u2 is going to the right. So it's going to be u1 minus u2 is going to be u1 minus u2, because u2 is going to the left. So effectively it gives you u1 plus u2. And then on the right we have minus v1 minus v2, which gives you v2 minus v1. So the correct answer there should be D. Hope that makes sense. Right, number 22. A box of mass 8 kg rests on a horizontal rough surface. A string attached to the box passes over a smooth pulley and supports a 2.0 kg mass at its other end. When the box is released, a friction force of 6 newtons acts on it. What is the acceleration of the box? Now this one again requires us to work it out, so I need to put it there for you to see. Now the 6 Newton force is going to the left, and then the box weighs 8 kg. That is, the mass is 8 kg, so it will be weighing 8 times g. And then T is pulling to the right, so the tension is pulling to the right. Now, the pulley, we are told the pulley is smooth, which means the tension is the same. So we've got the tension, horizontal tension, the vertical tension after the pulley should be the same, because there's no friction at the pulley. Now, the first case, the T minus 6, because the resultant motion is to the right when considering what's going on the rough surface. The resultant motion is to the right, so it's going to be T minus 6 is equal to mass times acceleration, which is 8 times acceleration, A. And then for the second one, which is pulling, you have weight, the weight of it minus tension is equal to mass times acceleration. So the weight is 2 times g minus the tension should equal the mass, which is 2a. Okay, so since these are a system of simultaneous equations, we could add, since the signs on T are not the same, so we add. So adding the 2 gives you 13.62 is equal to 10a. So A will be equal to 1.362, which is approximately 1.4. Answer is A there. I hope that makes sense. All right, moving on to the next question, number 23. A tennis ball of mass 100 grams is struck by a tennis racket. The velocity of the ball is changed as shown. What is the magnitude of the change in the momentum of the ball? So again, this one we need to work it out. So that will be that. So changed momentum is delta P is equal to mv minus mu, which is equal to minus m bracket v plus u, because remember we said that the final momentum is to the left, so it's going to be negative. So minus m bracket v plus u, and that should give you minus 5 kg meters per second. Now, since the question is requiring you to find the magnitude, so the magnitude will be positive, 5 kg meters per second. So the answer is B in this case. Right, number 24. A car of mass 750 kg has a horizontal driving force of 2 kilonewtons acting on it. It has a forward horizontal acceleration of 2 meters per second squared. What is the resistive force acting horizontally? Resistive force acting horizontally. Again, let's try and work this out again. So the driving force is to the right and the resistive force is to the left. So the resultant force is 750 times 2, which is mass times acceleration, and then driving force is 2000. So the statement is driving force, the 2000, minus resistive force is equal to mass times acceleration. Then you make resistive force the subject of the formula. It comes to be 500 newtons, which is 0.5 kilonewtons. Okay, moving on to the next question. Almost there now. Right. A ball is falling at terminal speed in still air. The forces acting on the ball are upthrust, viscous drag, and weight. What is the order of increasing magnitude of these three forces? A says upthrust, viscous drag, and weight. B says viscous drag, upthrust, and weight. Viscous drag, weight, and upthrust. Weight, upthrust, and viscous drag. Now, upthrust, you say since this object is moving at terminal speed, so which means that the two upward forces, upthrust and viscous drag, must balance the weight. There's no resultant force. So which means two of them are adding up to form the weight. So which means the weight must be greater than both of them. And then now determining which one is greater, upthrust or viscous drag. Upthrust should be small. Why? Because if we say the density of A, upthrust is equal to rho Vg, right? So the density of A times the volume times the G, which is the acceleration due to gravity. Density of A is small. V, that will be very small again, times G. So the upthrust should be very small. And also as the ball moves at terminal speed, the drag should almost equal the weight. So but it is smaller due to the fact that it has to be added together with upthrust to give the weight. So your answer there should be A. Number 26. A stationary body explodes into two components of masses m and 2m. The components gain kinetic energies x and y respectively. What is the value of the ratio x over y? So this one we need to work it out. That is number 26. We need to work it out. Now, number 26. First of all, x, it should be the kinetic energy of x, which is half mv squared of x. Then y is half bracket 2m vy squared. From the law of conservation of momentum, the momentum before was 0 because it was stationary, and then explodes. So final momentum px plus py. So which means px should equal minus py. Then making vx the subject there, you get vx is equal to 2vy, the magnitude of it. And then in terms of kinetic energies, we are now saying half mv x squared divided by half 2m vy squared. Right? So if the halves will cancel and then the m's will cancel, since vx is equal to 2vy, we are now saying 2vy in brackets all squared divided by 2vy squared. That should give you 4 over 2, which is 2. The answer there is C. If you have further queries on this one, please do ask. I can elaborate it further. Moving on. Number 27. Which statement about a ball that strikes a tennis racket and rebounds is always correct? Total kinetic energy of the ball is conserved. That is, if it's an elastic collision. It's not always elastic. Total kinetic energy of the system is conserved. It's not elastic. It's not always elastic. Then total momentum is conserved. That is correct. So total momentum is always conserved. Okay. Number 28. The diagram shows two spherical masses approaching each other head-on at an equal speed u. One is mass 2m and the other is mass m. Which diagram showing the situation after the collision shows the result of an elastic collision? Elastic collision. Now, in an elastic collision, total momentum is always conserved as well as total kinetic energy. And then there's another condition which says that the relative speed of approach should equal the relative speed of separation. So before collision, total momentum is 2mu minus mu, which is mu. And then relative speed of approach, remember we said u1 minus u2 should give u minus minus, that gives you 2u. And then after collision, you should get mu again. Then the relative speed of approach must also be 2u if it's an elastic collision. So I did a trial and error there to find out the relative speed of separation in each case. So for A, I got 2u. For B, I got 5u over 6. Then for C, I got 2/3 of u. minus u over 6, which is half u. And then for D, since they stick together, that one is a perfectly inelastic collision and the velocity of separation is 0, so that will be out. So the only one that gave me 2u is A, that is the relative speed of approach equal relative speed of separation of 2u. So the answer is A in this one. All right. Number 29. A supermarket trolley, total mass, we've done this one, and I think the answer there was 1.5 meters per second. Number 30. Two trolleys are placed together on a horizontal runway with a compressed spring between them. When they are released, the 2 kg trolley moves to the left at 2 meters per second. How much energy was stored in the spring? How much energy was stored in the spring? Now, this one, again, we need to work it out. Right, so according to the law of conservation of energy, the the energy that's going to be elastic potential energy should be converted to kinetic energy. That is, the energy stored is equal to the sum of the kinetic energy of the trolleys. Since the momentum is also conserved, we find the total momentum before the interaction day. It's 0 because initially they were stationary, and then when they are released, total momentum is equal to 2 times 2 for the first one, and then 1 times v for the second one, 1 kg times v. So v comes to be minus 4 meters per second. Now, to get the energy stored, you are now saying the kinetic energy of each of the trolleys, add them together to get the total energy stored, half m1 v1 squared plus half m2 v2 squared, which is half times 2 times 2 squared plus half times 1 times 4 squared. That gives you 12 joules. So that should be the total energy that's going to be stored in there. Right, so I think that marks the end of our test on kinematics and dynamics. Signing out.